with process mining, which is the usual talk we hear, but about what we can expect there to happen in the field of process mining in the next 5 years, I would say, in a 5 years horizon. And it's something that I call process mining 2.0. So, I mean, before I talk about what do we mean by process mining 2.0, let me say what do we mean by process mining 1.0. So process mining 1.0 has been traditionally about taking a data set, which we call an event log from an enterprise system, and basically doing like 4 types of operations. The first type of operation is automated process discovery, which means that from the event log, we discover a process model, right? So that's basically where process mining started, like more than a decade ago, even close to 2 decades. And we have seen, techniques evolving very, very rapidly in this field and being adopted by vendors and being used very widely to such an extent that sometimes when we talk process mining, we sometimes even mean just automated process discovery. But of course, there's more to it. Another capability in the field of process mining, which is relatively well known, is conformance checking, which means I now have a process model which I have automatically discovered, or it's an existing process model, and I have a set of rules, and I would like to compare the process model against the event log and to derive a number of diagnoses. What is that? Basically statements that tells me whether those business rules or process model are being followed. And you can think of a business rule, for example, as being that, like a given, for example, that a given purchase order should be approved and paid by 2 different people. So it cannot be the same person who approves an inbound invoice and the same person approves the corresponding payment, because that might mean that might be prone to a fraud. So some companies are using conformance checking also in the context of migration. For example, migrating from one version of an ERP system to another version of an ERP system to understand what will need to change in their performance of the process in order to adapt to the reference process model supported by the new ERP system. Then we have performance mining, which is I give you some sort of visualizations of a process model, and I take the event log from which I extract a number of performance measures. Could be cost-related measures, time-related measures, frequency-related measures, and I enhance the process model with those performance measures in order to understand the performance of the process. This is sometimes also called model enhancement. I mean, we prefer to call it performance mining because that's the goal. The goal is to understand the performance of the process. And then there is, next to that, there is variant analysis. Variant analysis means I take not one event log of a single process, but I take 2 event logs. And imagine I have an order to cash process. And in some of the cases in this process, the customer complained. And in others, the customer was satisfied. And I want to understand why is it that in some cases the customer complains and in the other cases the customer does not complain. So variant analysis consists in comparing these 2 subsets of cases where the customer complained, customers where they did not complain, and identifying what are the differences between them and possibly what are the root causes of those differences. So all this is what currently exists in the field of process mining. And to understand where are we heading, it's kind of, maybe it's good to take a step back and to go back to the broader field of data analytics, because we can say that process mining in a way is a subset of a broader field called data analytics. And the field of data analytics is often decomposed into 4 levels. Descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Descriptive analytics corresponds to techniques that allows you to describe the current state of affairs, for example, of a business process. Diagnostic analytics goes further. It's not about understanding, it's about determining how can I change the reality? What is the reason why certain things happen the way they happen, and what can I do about it? Predictive analytics is about predicting what is going to happen, and finally, prescriptive analytics is about not only predicting, but also using those predictions in order to determine how can I improve the current state of affairs. So it's about taking actions. The current state of affairs in process mining, which I would call process mining 1.0, is at the level of descriptive analytics and to some extent diagnostic analytics. Whereas we are seeing an evolution towards the upper layers of the stack, and that is process mining 2.0, which is heading in the direction of predictive and prescriptive process monitoring and automated process improvement. And today I want to basically summarize what's going on in this field of process mining 2.0, which is slowly cooking up on the background. So process mining 2.0, the current evolutions in the field of process mining 2.0, I can separate them into two levels. Some of them are targeting the operational level. So they are developing techniques for operational managers. For example, predictive dashboards that allows you to predict the future states of the cases in the process, the cases that are currently running, so that we can take immediate action to steer those cases in the right direction. Prescriptive process monitoring is about recommending actions on the basis of the predictions that you have previously generated and recommending some ways of rectifying certain defects. These recommendations at the operational level are destined to operational managers, are targeted at people who are going to take actions on an immediate basis or on a short-term basis in order to make it sure that the process achieves its objectives. And then at the tactical level, we have another set of tools that are targeted more at process analysts, process managers, process engineers, process developers. And these techniques are not like runtime techniques. They are not meant for you to take immediate action, but they are rather there for companies to automate and to improve their processes. And there we can see two current trends. One of them is called robotic process mining. And robotic process mining is the ability to discover routines that workers in a company are performing when they are doing a process and seeking automation opportunities, meaning trying to automate those routines. And search-based optimization is another family of techniques that tries to discover automatically how can we change the process in order to improve it with respect to one or more performance dimensions. For example, in terms of cost, or in terms of time, or in terms of quality, let's say the defect rate, etc. So I'm going to give an overview of where we are in the state of the art with respect to these four areas. Well, one area that has already reached quite some level of maturity is predictive process monitoring. Predictive process monitoring refers to, I am at a given point in a process, there's the current state, and I am asking questions about what will happen next. What will be the next activity in the case? When is this activity going to take place? How long is this case going to continue until it is finished? What is the outcome of this case? Or for example, let's say that I am doing an issue to resolution process. I might want to ask, will I have to pay compensation to this customer because of some complaint or not, etc. Or in an insurance claim handling scenario, how much will I have to pay to the customer for this particular claim they have just lodged? So predictive process monitoring generally starts from data in an enterprise systems from which we somehow extract a view called an event log, and this view is fed into is used to create a predictive model using machine learning techniques. And then at runtime, we get events from the enterprise systems, events about cases that are ongoing. We feed them into this we feed these events into the predictive models, and we derive various types of dashboards. Detailed dashboards, which tells me case by case what is happening in the process. For example, here I have a red saying, hey, this case here is currently running late, or aggregate dashboards, which tells me, oh, hey, in this region of the world, I have a lot of cases that are late, whereas in this region of the world, I am doing great. Well, always in Australia, people are doing great, by the way, except now with COVID. Or for example, here, I have an issue. I'm going to have an issue on this date with my sales, for example. So at an aggregate level. And then there are prescriptive dashboards, which I'm going to touch when I talk about prescriptive process monitoring. How these techniques work? Well, generally, you have an event log, you have extracted from an enterprise system, and we extract something called the feature vector. So, a way of representing the process as a matrix, where the rows are the traces and the columns are called features, which is like, more fine-grained than an attribute. So it's like if we take every attribute in the log and we start breaking it down, and by the way, each of these, in an event log, one row represents one event, whereas in one of these feature vectors, one of these rows represents an entire trace. And there are various methods for mapping a trace, an execution of a case in a process, into a feature vector. And with this table, and you don't need to understand the details, we can give it to these techniques called machine learning techniques, and we can get so-called classifiers or regressors, such that if I give an ongoing case, I'm going to get a prediction. Yes or no, the customer will complain, or I'm going to predict to you when will the case finish, meaning when will the customer pay, for example, if this is an invoice to pay process. Or from an event log, I can extract the same type of feature vectors, gives it to something called a structure predictor. Usually this is done using deep learning techniques, and these techniques allow me to predict step by step what is going to happen in the process, together with probabilities. Tell me what will be the probability that these 3 steps happen next. And that can be very useful in the context of resource allocation. All these techniques are actually embedded in Apromore in what we call the predictive monitoring dashboard, which takes an event log and gives it to a training module where you can either train using standard parameters, just give the log and say, train me the model, don't bother me about anything, and the machine does its best effort. Or you can actually, if you have some data scientists, they can take this training module and they can start tuning the parameters and getting a predictive model that fits the level of accuracy that you need for your business application. And then you deploy this predictor inside the so-called runtime module. And in the runtime module, there will be events being fed, possibly through an event stream, or being uploaded once a day, every day at 7 o'clock in the morning. And then this predictor will generate predictions that are going to be used to create predictive dashboards. And that's basically, how this technology works. If you go to apromore.org and you look for our user manual, you will get a little bit of a deeper overview of how this a runtime module and training module look like, and how the resulting predictive dashboards look like. Predictive monitoring has made a lot of advances, but it's not like a solved problem. So we still have a lot of challenges to address, in this field, particularly how to make the predictions generated in predictive process monitoring explainable, so that we can help users to understand the causes of our predictions and in turn help them to understand what can they do about it. And that is related, very tightly related, to making predictions actionable, turning predictions into actions or recommendations for actions, which is a field called prescriptive process monitoring. Roughly, prescriptive process monitoring works as follows. You take an incomplete trace of a running case in your process, like a purchase order that has not yet been completely fulfilled. You then build a predictive model using predictive monitoring engines. You then get traces of ongoing cases. And for every case that is currently running, it gives the probability, for example, that it will end in a negative outcome. For example, the probability that the customer will complain, or the probability that the customer will not pay the invoice, based on which you can generate alerts. And these alerts can be then customized according to some cost model. For example, you might want to say that creating an alert leads me to execute an action that costs quite a bit or less. And if I prevent the negative outcome, I gain something. And based on that, the alert generation system is going to decide whether or not to generate an alert in such a way as to minimize the net cost, or vice versa, maximize the net reward of your prescriptive monitoring system. This is to some extent something that is still evolving in the field. You will not find it really out of the box, that you have like predictions, turn into recommendations in a reliable manner, because reliability is very important in this setting, and being able to estimate the uncertainty of a prediction is very important. And that question of estimating uncertainty in an accurate manner is still quite a bit of an open question that is still being studied in the field. But we will start to see more and more mature prescriptive process monitoring systems evolving in the next few years. So I talked about process mining 2.0 at the operational level, predictive process monitoring and prescriptive process monitoring. And let me talk a little bit now about how things are going to evolve at the tactical management level, how process mining is going to be helping tactical managers like process owners or process analysts to improve their processes in the next 5 years. So this is the vision that I have of that. There is an enterprise system where there is a mine gold of data about the execution of your processes. And there might be some additional external source of data like IoT data, web and social media data that you will then feed into what we call a search-based process optimizer. A search-based process optimizer is a machine that basically takes the current process and starts changing it in all sorts of directions, and then finds that, oh, here there is a better version of the process, and then takes that version of the process and gives it to you. And that is all done using domain knowledge, which is the big challenge in here, the big bottleneck in automated process improvement. How can we provide meaningful recommendations for improving the process while not requiring unreasonable amounts of domain knowledge? Because if we require you to put your entire brain into the optimizer, then, well, that's putting your brain somewhere is not possible, really. So we need to find out smart ways of gathering this domain knowledge that will allow us to determine what changes can be made to the process and to what extent it is likely that a change is going to improve the process. But based on that, we expect that we're going to get some possible process improvements. Think about this as a process improvement, and I will give some examples in a minute. And we want to find which process improvements are better with respect to different performance measures, which could be cycle time or resource cost. This is some example. To make this more concrete, I'll take an example. Maybe take this incredibly simple, simplified loan application processing process, where I receive a credit application, I do a number of checks, I assess the application, I decide if it's granted or not, and I notify the customer whether the thing is granted or not. And the customer might ask me to review the decision and provide me additional material to inform my decision. So one possible improvement that we could derive by looking at the event logs. I don't need the process model. I'm just showing it to you to make the ideas clear. But just by looking at the data, I might find that it is better in the case of consumer loans as opposed to other types of loans like mortgage loans. It is better to check the income sources before checking the credit history. Why could that be the case, that this is better executed before than that? It might be that in most cases, the reason why we do not issue the consumer loan is because of the income source rather than the credit history. Therefore, it is better to then check for the income source, and if there is a problem, to go back to the customer or stop the case. And if this check passes, then we can go and check the credit history. Another possible improvement is that for customers who are already, customers of the bank and who have previous recent loans, there is no point in doing the credit history check. But for other customers, sure, you should do the credit history check. So So depending on, we can discover conditions of like, in these cases, there's no point in doing something. In those cases, it's important to do something based on what we have observed in past cases, in historical cases. Or we might find out that if the credit rating of the customer is C or D on a scale of A to F, we do not need to wait for an appeal because anyway, we will reject the appeal. So let's close the case immediately. If the credit rating is C or D, let's tell the customer there is no possibility of reviewing the decision. We might, for example, find out by looking at the resources, for example, all our clerks and the workload that we get on different days of the week, that it's better to allocate an additional clerk on Mondays and Tuesdays. On the other hand, maybe we need one less credit officer on Fridays. So that's the kind of rules we want to find. Or if a loan to annual income ratio is greater than 1.5, this is a performance metric in this field, we can allocate a senior credit officer to this application because that means this is a tricky case that requires a special attention. Whereas if the loan to annual income ratio is less than 1.5, then we can give a chance to a more junior person to assess this application. Or we might discover that, hey, this is a task here where all you're doing is copy-pasting from one place to another. This could be automated using a robotic process automation bot. So given one or more event logs, given one or more performance measures that we want to maximize or minimize, possibly given a process model, some decision rules and resource allocation rules, and a set of allowed changes, this is the domain knowledge, then what we seek is to find possible sets of changes to the process to optimize the performance measures that we have defined. And there are many ways of doing that. 4 main ways, and this is where I see process mining 2.0 going, is 4 directions. First, from execution data and some domain knowledge, we can find routines in a log that can be automated. And we already kind of have a prototype of that. It's called Robidium, that is able to do just what I'm saying here. Or we can look at the execution data and find opportunities for optimizing the flow in the process. As I said before, for example, finding that in some cases, not in all, but in some, it's better to execute this task before executing that task, even though in general this task can be done in any order. Or given what we have observed in the past, the way we are currently deciding on which customers to reject or not is maybe not optimal, given the outcomes that we have observed and the behaviors that we have, repayment behaviors that we have observed. So we might kind of try to optimize the decision rules that we are using to route the customers to the different branches of the process. Or we might find that there are possibilities of better allocating resources to tasks in the process, maybe increasing the number of resources of a certain type on a given day of the week, decreasing them on other days of the week. Robotic process mining, the first of these things, is a very exciting field. It allows me, it's a set of techniques that allows me to take a user interface log, which is like an event log, but there are timestamps, but the actions are very fine-grained actions like copying from a cell in Excel, clicking on a field in Excel or in the browser, pasting some data, editing a field, editing a cell, etc. And I can see what data I enter and what data got out into the clipboard and so on. And based on that, I can identify that there are some patterns in the data that allows me to automate it. And from there, I can derive a script that I can load into a robotic process automation tool to automate my process. And a task, basically a task we are looking for are automatable tasks that every step can be performed deterministically based on data or decisions we have seen before. And for example, we can discover, for example, that copying this type of records from Excel into a form in an ERP system like this one is very mechanic. You are taking this one, putting it here, concatenating this one to this one, you are putting this one here and changing a little bit the slashes into dashes, and we are putting this to here and removing the country code and putting a 0, at least for some cases. And we are taking this address and we are breaking it out into pieces, zip code, country, etc. So this is all mechanic work, that people are repeatedly doing day in, day out. And this kind of routines we have shown in our previous work earlier this year and last year that we can actually automate it. And we have automated it, built a tool called Robidium that takes a user interface log like the one I found it, simplifies it, cuts it down into pieces, segments the UI logs and therefore extracts a routine and therefore generates a number of candidate routines. And these candidate routines are evaluated to determine which ones are automatable. And those automatable routines, from those automatable routines, we can synthesize, we call it, an RPA script using techniques from the field of program synthesis, which is a very exciting field, where if you give me examples of what you want, inputs and outputs, I can synthesize a program for you. In this case, we can synthesize a robotic process automation script that can do exactly this type of copy-paste task that I described before. I guess in the interest of time and to allow some time for questions, I will just summarize the other areas of robotic process automation. So in addition to automated process improvement, in addition to automating tasks, automated process improvement is also about improving the allocation of resources, optimizing the flow, optimizing the decision rules, and composing different types of changes. One of the key questions that we pose in this case is like, imagine I come up with a change. Let's allocate more resources to a task. How can I determine if a given process change will improve a business process and how much? If we have the data, this question can be answered by means of data-driven process simulation. I can take an event log, I can feed it into one of these tools. One of the tools that does that is called CMOD. And CMOD will discover a BPMN model from the event log using existing automated process discovery techniques. It will use conformance checking or so-called trace alignment techniques to make sure that all the traces in my log fit the model, and then it will do a number of parameter extraction steps. It will extract the resource, it will extract the inter-arrival distributions, the activity duration distribution, the task assignment, the branching probabilities to build a simulation model, a BPMN model with simulation parameters that I can give into a simulator such as PIMP, and it tells me, how will this process perform? So by means of simulation. And then I can make changes to the process and I can repeat this. I can make one change, another change, another change, try different types of changes, and then come up with a better way of executing my process. And this is what search-based optimization is about. It's about, from an event log, discovering a simulation model, discovering a process model that's part of the simulation model, that's my assist process model, and from here, applying a technique from the field of artificial intelligence called meta-heuristic optimization, including genetic algorithms, to compute what are the possible ways of improving the process, pruning that down, and determining what are the best ways of improving the process using the business process simulator and the simulation model I discovered here as a way to determine how good is a given change to the process. And then I tried lots of changes using these genetic algorithms, and I select the most promising changes, and I then present them to the analyst so that they can do a more in-depth evaluation of these improvement opportunities using their domain knowledge. So then I get a space of improvement opportunities that the analyst would then look into. And this is something we are doing in the context of the project, the Process Improvement Explorer, PIX, which is a project that runs from 2019 to 2024, funded by the European Research Council, and that seeks to develop AI techniques for automated process improvement, including robotic process mining, but also search-based process optimization. And this concludes my overview of where we are heading in this field, and I will be very happy to answer some questions.